Hello, can you hear me? Are you on mute? Yes, you're on mute. Hello, am I audible?
Yeah, you're audible. I can hear you.
Hi, welcome. How are you? Everything all right?
Yeah, I'm fine, thank you.
Okay, so how can I pronounce your name?
Just call me Faithfulness.
Faithfulness. Okay.
Yeah.
Okay. Okay, faithfulness. That's nice. Let me share my screen to you quickly and hopefully you are having a wonderful day. You are from UK?
Yes, I am.
Okay, perfect. So we'll start, I guess, from chemistry, right? Is it fine for you?
Yes.
Okay. So let me see what specific thing they have sent me to give you a demo on for chemistry. Okay. So yeah, I just love to tell quick intro about my own self. My name is Faiz and I've been like teacher and a software developer as well. I've been working in a company called the Access Group in UK and yeah, just teaching from 7 8 years also. Just to let you know about my own self a bit. And yeah, do you have any specific hobbies that you follow? Like
Do I have any specific hobbies?
yeah, like except studying, like anything that you like a lot.
Oh, I like to sing. I like to cook.
Okay,
Mm, I like reading books,
that's very
and I like to yeah,
amazing.
and I like to hang out with my brothers.
Okay, with your brothers,
Yeah.
that's really awesome. Great. What book you have read recently? Like you read non-fiction or fiction?
I read different types of book books. I've read poetry, a book with different poems. I've read Atomic Habits. I've
Ah,
read some medical books.
some
And
medical.
yeah.
Okay, that's very nice. Awesome.
Mhm.
Okay, perfect. This is just to make sure we have a bit uh intro about each ourselves. By the way, let's start with the thing. So that I have seen the topic the coordinator has sent me is about the model of matter, the particular nature of matter. So we could quickly have
Yeah.
usually. Sorry, say it again, please. Sorry. You were about to say something.
Um,
Yeah.
no, no, no.
Okay, so I was just telling you that particularly I just prepare a PPT also for the students' better understanding. But again, right now I'll just give you an idea about how we will do it. Or sometimes when we are doing numericals or maths, we usually do it on the board because obviously PPT doesn't work for maths. But for chemistry like subjects, I try to explain through that only so that the student understand better with pictures and stuff, and it is like a better understanding. Firstly, that. Second thing, let's start with this chapter now. It's without wasting any time. Model of matter, the particulate nature of matter. That is the first thing. Now we will try to understand in this chapter what is this chapter is actually about. So we'll try to understand the physical properties of solid, liquid, and gas. We will try to understand what is really a particulate nature and like particulate nature of matter. We will also try to understand the arrangement, the movement, the attractive forces, and kinetic energy of of particles, sorry, in matter. And we will understand diffusion. In this chapter, usually, like very commonly, when you study about something very commonly, this is what this chapter is about actually. And obviously, there are some other topics also that can be there accordingly. So I would love to ask you the first question. According to you, what is matter? Like, according to you, what is matter, and what do you understand from the chapter when you read the heading or you came across this kind of a chapter? What do you understand from this?
Mm, well, I think matter is anything that is made from atoms.
Anything that is made up of atoms?
Yeah.
Okay, that's perfect. And what else do you know about this chapter? This is not like to Like this is about to understand about how your mind works towards the chapter, towards the words that you see around. That is just to understand you better
Mm,
as a student so that we can accordingly make the PPTs or any such thing actually, right? Yeah.
yeah. I also know that
Mm-hmm.
energy is involved, but I don't know what role it plays.
Okay, energy is okay, fine, that's fine. And if I will ask you, maybe you know about anything in the past you have studied about diffusion also. So what you will say, have you studied anything about diffusion also? Like you know about, yeah, diffusion,
Mm,
this or that, any such thing?
we didn't really talk about diffusion.
Okay, you haven't ever talked about it, never. Okay, fine. So, well, these are some of the two topics that I want to ask you before I start, obviously, that what is matter and stuff. Now, I'll tell you very like in a way that you can understand, not in a bookish language actually, which I can obviously through PPTs. I will do that also. But try today, I'll try to explain at least chemistry with a with like imagination actually, or in a storytelling way, so that you can understand it better. And yeah, this type of approach is very different from other teachers, obviously. So, first thing is that when you talk about the nature of matter, the properties of solid, liquid, and gases, and diffusion, you can imagine that, like, for example, you are visiting three magical kingdoms. Like, this is what I feel when I think about it with creativity, that actually represent the solid, liquid, and gas. So, the first is the kingdom of solid, or you can say solid, okay? Uh, I will
Yeah.
write down the points also, but try to understand this way first, and then we will write down some of the points. I'll just make sure that you have. So let's say in there is a land, there is a kingdom which is called Solid Valley, and the people here, usually the particles, they are very well behaved. So they have like strict rules about staying in their place. So each person has their own spot, and while they can wiggle just a tiny bit like vibration, they never leave their position. These people are like packed very tightly together, like in neat rows, and almost like soldiers. Like you have seen soldiers of like the army. So this close
Yeah.
arrangement actually gives solid their fixed shape and their hardness. So if you talk about solids, you have to remember two things, which I have told you that in the story also. Firstly, what is matter again? You already know. In case if I'll start with matter, which you already answered me, the matter is basically anything that has mass and occupies space. That is the first thing. Second, obviously, now I'm telling you specific thing about this solid. There are like three types of things we will study: solid, liquid, and gas. And that is the three kingdoms that I just told you so that you can understand it better. So the first kingdom, which is basically solid. Now in solid, if you talked about the arrangement that it gives solid gives you fixed shapes, and I told you how also, and hardness. These are the two properties of solid usually. Even if I'll tell you more about solid, their horses, they are built so strong because the attractive forces between them are very high. Okay, so you can also write down in solid that they have strong attractive forces. And while I'm telling you this story, imagine that kingdom also in UK. I mean, if you just imagine it, it will be much better. You will remember it actually with the imagination part. So they have attractive forces between them. They are very, very high. They have a strong attractive forces. They are high. They have which are very high also. Now imagine that they are holding hands very tightly. So actually, it is hard to break them apart since they hardly move from their spots. So the kinetic energy, what is this kinetic energy? Energy of movement actually. Kinetic energy in a very simple terms, I'll tell you. Energy of movement. So kinetic energy they have is quite low. So you can write down they have uh, what I just said. Yeah, they have a low kinetic energy. Low kinetic energy. Then what else? Well, uh I mean, by low kinetic energy, by the way, I mean that they don't move around much. Okay. So if you were to
Yeah.
visit this solid village and you tried to push them apart, they wouldn't, they wouldn't budge easily. They That's why solids are like rocks or metals. They are so hard to bend or break, basically. So that was about the matter, the kingdom of solid, I would say. Then let's talk about the kingdom of liquid, which we call it as maybe liquid area. Okay, the kingdom of liquids. So it's a neighboring kingdom, let's say, and here the people are like more relaxed. They can move around each other, but they still stay close, almost like dancing in a circle. So like the people, which are basically particles, okay? So you can think them like the people as, let's say the name of the people right now is particles. They are in liquid area, I mean the liquid kingdom, and they don't have fixed spots like those in solid village. So, but they also don't go too far from each other as well. So since they move around like liquids, so that you can say that liquids can flow and also can take the shape of any container like that, when wherever you put them in. So that's one thing. If you pour water into a cup, let's say, and it fills up the cup in that shape, it will again, you know about liquid, right? So that's how it works. However, I would also like to say here that they can't fly away. Like these particles or these people in liquid area, in liquid kingdom, they can't fly away or spread too far because they are still somewhat attached to each other. Like, but less so like in solid village. So it's like they are holding hands but loosely. They can let go, but they like to stay near to each other. It's like a kind of a best friends, which can be to like which can hang around, but maybe just go out and chill with other friends as well. So liquid, in liquid area, in liquid kingdom, things works like that. In case of their kinetic energy we talk about, by the way, are you getting this way or not?
Yeah, I'm getting it.
Hopefully you are getting it then. So the kinetic energy, if I talk about, let's say the kinetic energy here is higher actually here, which is the energy of movement. So it is higher than in the solid village, which is the kingdom of solid, which means the particles move more freely. So you can write down, because here, because the particles or the people, or you can say particles move more freely. And and even if they are moving freely, by the way, they are still close, but they move around. They are like more compared to the solid particle, as compared to the solid particles, kind of that. So that was about the liquid kingdom, liquid area. Now third one was, or is actually, gases, which we call, which we can call, uh let's say what, the kingdom name can be, let's say, anything, gasopolis, any such thing. Just a random word I'm making, but like here everything is wild and free. Like it's kind of a jungle. The people here are always running around in every direction, bumping into each other, like lions do. But they're never but lions do stay together, but they're never staying together for long, like in Gasopolis, like the kingdom of gases. uh they're definitely bumping into each other, but they're never together. They are spread far apart, and there is no strict rules to follow like in solid village and liquid area, because um because of this reason, gases can fill any space they are in. Like if you open a perfume bottle in one corner of the room, soon you can smell it in the entire room. That's because the people of Gasopolis, like the particles, they love to explore everywhere. They just love it. So they have a lot of kinetic energy. So that's also, I mean, you can write that about as well, which we will write down. And The attractive forces between them are weak. Means the attraction basically is weak. So in Gasopolis, it's kind of yeah, just uh two males, like or I don't know about the female versions, but let's say two males. The forces between them is too loose, too weak, so they don't like to stay close to each other. Like two lions never like to, they are always fighting in the jungle for the kingdom. So it's like gases are like just moving around, uh, all of that. So if you visit the Gasopolis, like the kingdom of gases, and try to trap them in the small area, they will keep trying to escape, always, always. And they spread out and they fill the space that you give them. Doesn't matter how big the space is, they just fill it. So that was Gasopolis. But let's write down some of the points also here. So we will write down the first is that mm, they are spread far apart, and there are no strict rule because they can fill up any space. So I will just write down that in gases, the shape is not fixed. The shape is not fixed in this thing. The shape is not fixed, and also the more space they have, they can occupy it. Means the volume is also not fixed. Okay, means the volume is also not fixed. They can be, definitely they can be compressed also, but if we talk about the kinetic energy, lots of kinetic energy means that they can move, they have a lot of energy of movement. So you can write down they have lots of kinetic energy.
Mm.
And attractive forces, as I mentioned to you about them by giving you random examples. Attractive forces between them are very weak. That's the thing here. Is it clear, miss?
Yes, it's very clear.
Amazing. Do you know about this chapter already?
Yes, we've done this chapter.
Oh, okay then. I mean, I'm just trying to tell you in a like a demo way, like how will we do it, or what is my way to present the chapters. You might, if you don't like it, I definitely can tell you in a straight way also, but it just make the chapter more interesting, I feel, because the normal way you study everywhere, usually I have a presentation to present and then the speak, and the points are obviously written. The bookish points are always written on the screen, and I just try to explain you that this is that, this is this, and this kind of a story I present to you, so that the student can definitely indulge it. You, this way you will be able to understand it and you can enjoy the lesson more. But yeah, in case if, because some student definitely will not like it, maybe some do like it. So it's depend on student to student. As I will know you better as a student, I will mold accordingly, like how fast you want, how slow you want. I just know you better, as like I just want to know you as a student for now, for now, so that we can make sure that things happen better for us, like for you, and you understand it better. But yeah, this is how we do things over. Let's just continue this quickly, and then we will also discuss some other subjects as well. Diffusion, right? The magic of diffusion. Now we will talk about that because you haven't studied it still, as you mentioned about it. So I'll just quickly tell you about it, and then whenever you join for the regular session, I'll just ask you what specific thing you want to discuss or what chapter. Make a PPT. Accordingly, we will study this style. Or if even if you want to do numericals, doesn't like will be easy, super easy for us. By the way, the magic of diffusion. So let's say one day in the land of Gasopolis, which is the kingdom of gases, someone opened a jar of perfume, and the people, which were basically the particles inside the jar, who are like very, very energetic, as I mentioned to you, the movement, kinetic movement is so much. They immediately rushed out of that jar and they spread throughout the entire room. Now, this process of particles moving from an area where they are crowded like a jar to an area where there is like more space, the room basically, that is called diffusion. Like diffusion usually happens in gases because the particles are always moving and bumping into each other. Like they're spreading out to fill the space. And this can also happen in liquids if you put some dye in water. Like the dye slowly spreads out until it's evenly distributed throughout the water. So that can definitely happen. But diffusion are what? Particles naturally move from the areas. I'll write down now. So particles, usually what exactly the diffusion is, naturally uh moves out, moves from areas of high concentration, okay, to low concentration, like how perfume spreads in a room. Now, obviously, the bookish language can be more straightforward, which I can also tell you directly that what is like kind of diffusion definition and directly like that. Like what is diffusion? If you read the bookish language, it will say that, diffusion is the net movement of the particles, which is like the total movement basically of particles from a region of higher concentration to the region of lower concentration. But I just tell you that particles means people naturally they move from higher areas of higher concentration to the low concentration, like how perfume is spread in a room, which is very similar, but again, it depends on the bookish language. If you want, you can definitely go for that reason, like for that thing also. By the way, whatever we do on the specific board purpose, like in maths and stuff, you can definitely get the PDF of that too immediately after the classes. So that is also one thing that I can provide you with that thing. So hopefully you understood this part. Did you? Did you get this thing?
Yeah, I do.
Amazing.
I understand.
Did you have any specific doubt in these three topics, like maybe which you have studied in school and you think like, I didn't really understood what this question means, or what I didn't get this part of, like specifically from these topics, what I have taught you right now.
Wait, what you have taught or what
Yeah,
my
yeah,
school has taught me on this topic?
yeah. What like same topic, any kind of doubt, doesn't matter you have studied in school or here.
Okay, so in my school, we looked on melting point on
Yeah.
how to determine the melting point of different substances,
Mm-hmm.
and I don't understand how that works.
Okay, okay, no worries. I can just tell you like very easily. Uh, Quickly on the board right away, as you have mentioned to me. So
Yeah.
yeah, yeah, I get it totally what you mentioned. So again, it depends totally, but I will just tell you so many things over here, which you have to do basically. So there can be a lot of points, like if you want to tell the, like if you want to specifically tell the melting point of different substances, so there are some steps. First of all, did they have, like as you mentioned, the substances? So obviously in that case, it is kind of a question where you have to reach it in a different way. Obviously different way, I mean by that is, like for example, let's say you have to, like there is a sample of that thing that you are that is that like whatever substance you are measuring for, like whose melting point you want to know. So there should be a sample of it. First of all, make sure that it is in its solid form, or you can say like in a powdered form, like where you can, if it has an accuracy, it will be better. So if the substance is impure, its melting point might be lower or less precise due to be maybe because of its impurities. Do you have any specific like melting point question with you right now? Like any specific substance question or something like that, so that I can just be very precise of what you asked. Otherwise, there I can tell you like the steps where like you heat actually the sample slowly, which I did in my chemistry lab. Like literally when you have this kind of a question and if you do it practically, what you do is actually you prepare the sample, Like you have the sample. Usually our teachers usually give these samples to us. When you have these samples, you set up the apparatus, like the things that you need for it, like maybe capillary tube, thermometer, all of that, and you heat the sample slowly. When you do so, you observe the sample, and the melting point is determined by recording the temperature when the solid start into the liquid, right? So that's how it happens. You record the
Yeah.
temperature, and uh, as soon as you see the solid begin to melt, it becomes like shiny or start turning into a liquid. You record the temperature. Once your entire sample has melted completely, you can note the final melting temperature. And then it usually reported as the range between these two temperatures. Like through from pure substances, the range will be like very small. Like you can just subtract the ranges and you can actually get the answer. For example, uh, yeah, I mean that's one thing you can for purity check also. I guess we used to do uh like a pure substance usually has a specific narrow melting point range, whereas when there are like impurities lower the melting point, they broaden the range. Like the because of impurities, the range is broader, but it's very narrowish when you have the purity, like when you have the pure substance basically. So it depends on the purity basically. Okay, that's not the question, but yeah, I want to know in case if you have any specific sample, or is that what was the question that you have asked?
Not really. I don't have a question with me now.
Okay, faithfulness, then no worries. I hope so that you have gotten the thing that I have told you. But in case if you have any specific question, please just maybe just send it to the coordinator, and it will be great for me to see that. And I'll can explain you everything that you need to know. But this is how you do it in chemistry lab, as I mentioned to you. But yeah, in case of any specific numerical type of question that you want to know, just send it to me, and I'll tell you how and specifically what you have to do to figure it out, that kind of a thing. Hopefully you like the chemistry
Okay.
demo. This is how you do it.
Yes.
Yeah. So what next demo do you want, miss? I mean, I guess maths or bio.
Uh,
I guess yeah, polynomials you have mentioned. So can we restart the meeting, because I'll just send it to the company for like the demo, for the checking purpose that we had the demo, and they will check it out. And yeah, they will inform you like any other thing you need. So we can do one thing. We can restart the meeting separately, and we can start with the maths or bio, whatever you want. Okay, is that
okay.
works? Yeah. The same meeting ID
So
you have.
should I leave the meeting and then come back again?
Yeah, rejoin exactly. Just click it, like cancel it, click it again. It just take you like 2 seconds, I guess. Okay,
Okay.
perfect.
Yeah.
Thank you so much. Yeah.